Study of gas laws. Different types of molecular speeds. The molecules of a gas moves very fast, but their speed constantly changes due to collisions. For a quantitative description of the behavior of gases, three different types of molecular speeds are described as the gas molecules. These three speeds are most probable speed, average speed, root mean square speed. We'll discuss them one by one. Most probable speed. Most probable speed of a gas at a given temperature is defined as the speed possessed by maximum fraction of the total number of molecules at that temperature. It is given as follows: speed most probable, that is equal to square root of 2RT by m. The next speed is average speed. It is defined as the arithmetic mean of the speeds of different molecules of the gas at a given temperature. If all the n molecules of the gas are considered to possess different speeds, for example V1, V2, V3, etc., centimeter per second, then speed can be expressed as u average speed, that is equals to V1 plus V2 plus V3 plus Vn upon n, total number of molecules. On the other hand, if n1 molecules of the gas have speed v1 centimeter per second, n2 molecules have speed v2 centimeter per second, and n3 molecules have speed v3 centimeter per second, and so on, then it is expressed as follows. Then speed can be represented as average speed equals to n1 v1 plus n2 v2 plus n3 v3 plus so on upon n1 plus n2 plus n3 plus so on. Here average speed is related to temperature as U average, that is equals to square root of 8 RT upon pi m. Then the third speed is root means square speed. It is defined as the square root of the mean of the squares of the different speeds. If all the molecules are assumed to have different velocities, for example v1, v2, v3 and so on, vn centimeter per second, then it is expressed as follows. Then Rootman's square speed is represented as URMS, that is equals to square root of squares of the velocities v1 square plus v2 square plus v3 square upon n. On the other hand, if n1 molecules have velocity v1 centimeter per second, n2 molecules have velocity v2 centimeter per second, and 3 molecules have velocity v3 centimeter per second, and so on, then it is represented as follows. Then root means square speed URMS, that is equals to square root of n1 v1 square plus n2 v2 square plus n3 v3 square plus so on upon n1 plus n2 plus n3 and so on. URMS is related to temperature as URMS, that is equals to square root of 3 RT upon M. Now we'll represent it with the distribution of molecular speed of chlorine and nitrogen at 300 Kelvin. This is graph showing distribution of molecular speed of Cl2 and N2 at 300 Kelvin. In the graph on the one axis there is fraction of molecules, on the other axis there is molecular speed of Cl2 and N2. The graph is rising high, that is for chlorine, and graph rising low, that is for nitrogen at 300 Kelvin. It is also observed from the above relationship that speed of a gas molecule at a given temperature also depends upon its molecular mass. Lighter the molecules, more is their speed. Thus, lighter value of most probable velocity than chlorine molecules. Now, relationship between different types of molecular speeds. The three different kind of molecular speeds are related to each other as follows. Most probable speed is to average speed is to root mean square speed, RMS speed. Most probable speed is under root 2 RT by M. Average speed is under root 8 RT by pi M. And RMS speed is under root 3 RT by M. And ratio comes under root 2 is to under root 8 upon pi is to under root 3. That is equals to 1 is to 1.128 is to 1.224. Now, numerical example to understand the speeds. Calculate the root mean square velocity of a molecule of sulfur dioxide at STP. What is its most probable velocity? The solution is volume of 1 mole of SO2 at STP, that is 22,400 ml. Molecular mass of SO2, that is equals to 64 AMU. The pressure in dynes per centimeter square, that is 76 into 13.6 into 981. The root mean square velocity will be obtained by substituting the values in the formula. URMS equals to square root of 3 PV by M, as PV equals to RT for 1 mole of a gas. URMS is equals to square root of 3 into pressure 76 into 13.6 into 981 multiplied by volume 22,400 ml upon molecular mass 64. Root mean square velocity comes 3.263 into 10 raised to power 4 centimeter per second. And most probable velocity, that is equals to 0.82 into u RMS, that is equals to 0.82 multiplied by 3.263 into 10 raised to power 4, that is 2.676 into 10 raised to power 4 centimeter per second.